Hello students, so in this video I will be discussing about I'll perform an experiment to show you the differences between three types of mixtures. First, let us understand what is mixture. Mixture is actually an impure form of matter. So matter can be classified as pure and impure form. Pure matter is those which are made up of same type of particles, like a piece of gold. It will be made up of atoms of gold, or if we take water, there will be only molecules of water. But if you are mixing something, two or more things you are taking and simply physically mixing it, that gives you a mixture. Suppose you take salt and sugar and you mix it, that's a mixture of salt and sugar. If you are taking oil and water and mix it, that will give you a mixture of oil and water. So that is what we know as mixture. And mixture, since it is formed by simple physical mixing of substances, so every individual component will maintain its property. For example, if you take a mixture of salt and sugar, you will, and you taste it, you will get taste of both salt as well as sugar. That means they maintain their property. And since the mixture is formed by simple physical mixing, similarly, the components can also be separated easily by simple physical mixing. So mixture, in the mixture, depending on the mixing of the components, sometimes the components are very uniformly mixed. Such mixtures are called your solutions or homogeneous mixture. Homogeneous mixture is of one type, that is solution. Suppose salt solution, because throughout the salt solution the salt will be uniformly distributed, that's why homogeneous mixture. And another type is heterogeneous mixture, which is of two types. One is called colloids. Milk is a very good example of colloid. And another one is your suspension. Suppose sand in water, that's in suspension. So these are heterogeneous. Colloids and suspensions are heterogeneous because the particles are not uniformly mixed. So we'll try to create the three types of mixture, that is your solution, colloid and suspension, and try to see the difference between them. So in 3 glasses I take water. In the first glass, what I do, I take little sugar. I take little sugar and I put it into the water. So after that I stir this. So as the sugar dissolves, so that will create a kind of sugar solution. So if you want to do it quicker, it's better to take salt, because salt dissolves much faster compared to sugar crystals, because sugar crystals are bigger in size. And in the other glass we take some powdered milk. So I have taken powdered milk and I have put here. So stir it and mix it out. And in the third one, I will take a kind of solution, normally easily available solution in your home. You have this antacid. So if you see properly, it will be written kind of suspension is written here, so you can see that. So what we do is we take this suspension and pour little suspension. It is already created suspension, so we pour it in water. So first thing is that, first difference, what is the comparative properties that we'll study? First is whether it is homogeneous or heterogeneous. Now if you see, this is a solution. So whatever sugar has dissolved, let me dissolve the whole sugar, then it will be, the concept will be clear to you. Okay, the entire sugar has got dissolved now. So what happens is that, if you see, it is a very clear solution. The solution is very clear. Okay, and it is homogeneous. Homogeneous means we can see that it is quite uniform. You cannot see that there are some sugar up or bottom or something like that. The sugar has got dissolved uniformly. If you look at this, where I have you can say milk. So in milk also, if you see, it is quite uniform. So it is also homogeneous in appearance, but actually it is not homogeneous. It is heterogeneous. There is colloid. Second one is colloid. So colloid appears to be homogeneous, but actually it is heterogeneous. Why it is heterogeneous? Because in case of milk, there are fat particles. Fat particles are lighter, they will remain on top, and milk proteins are heavy, they will occupy the lower position. So they are actually heterogeneous, but they appear to be homogeneous. And here you can clearly see the heavy particles have settled down, and on top we have a clear water or clear solution. So it is heterogeneous, it is not uniform mixing. So that is the first difference. This is solutions are homogeneous, colloids appear to be homogeneous but are actually heterogeneous, and this is suspension, suspension is heterogeneous. The next property that we'll be discussing is visibility of particles. So if you see clearly, you cannot see any particles here. So actually, in case of solution, the particles are not visible to our naked eye because they are too small, less than 1 nanometer. Whereas in case of colloids also, the particles are quite small to be seen with naked eye. Okay, their size lies between 1 to 100 nanometer. So if you take milk, you will not be able to see any solid particles in milk. Okay, so here also the particles are not visible to the naked eye. But here if you see, in case of suspension, the particles are clearly visible. So though the particle size is more than 100 nanometer, but it is much larger than that, so that they are visible to our naked eye. So that is the visibility of particles. Third comparative property is your stability. Now when we talk about stability, you see that this is a sugar solution. I have left it for quite long, but still the sugar hasn't settled down. Here also you have seen I have mixed milk powder, but you haven't seen anything settling down. So when we talk about stability, solutions are stable mixture, colloids are also stable mixture. But in case of your suspension, if I mix it up and you leave it, again you will find that the particles are settling down. No matter how much you mix, you leave it, you see that the particles are slowly settling down. So suspensions are unstable mixture. So that is the stability comparison, that solutions and colloids are stable mixtures, but suspension is unstable mixture. Next we come to let's talk about scattering of light. Scattering of light means what? You must have seen that when we walk through a jungle, we can see rays of light entering through the leaves or through the trees. So, or in a dark room, when light enters through one small hole, you can see the path of the light. Why? Because when light hits against dust particles or fog, it spreads. So when light spreads, then you can see the path of light actually, and that is called scattering of light. Now I will try to show you whether light gets scattered by which of these mixture, whether it gets scattered by your solution, colloid, or suspension. So I will switch off the light. After that, okay, fine. So this was your, get this away. Okay, so this was your solution. So if I bring this light here, you can see inside the glass, you cannot see any ray of light passing through it. So it is absolutely clear, and generally solutions, they do not cause scattering of light. But if you look at milk, this was colloid. If I put this light against the milk, so inside the milk you can see the beam of light passing through the colloid. So that is an example of scattering of light. And in case of suspension also, if we place the light against the suspension, so you see that the entire suspension has got actually lighted up. That means it is causing scattering of light. But again I bring back solution and you see the difference. The solution is absolutely clear. Okay, there is no, you cannot see that the solution is getting lighted up, just like in case of colloids or suspension. So what we come to know is that it is more nicely seen if you use a kind of laser. So solutions do not cause scattering of light. Colloids and suspension, they cause scattering of light. The last property, comparative property that we'll see is their separation of the particles. Now suppose I take a mug here, so I won't be using a filter paper. Rather, instead of filter paper, I'll be using a kind of cloth, a cotton cloth. Okay, so first let me take the solution and pour it. So as I pour it, what we find in the cloth, if you see in the cloth, there is no particle which is stuck and the entire solution has come out. So the components of solution or the particles of solution are too small to be separated by filtration. You cannot separate them by the process of filtration. Next, again I put this cloth here. Now I will try filtering the milk. So I poured the milk. So what do you find? That the entire milk has got filtered out. It's not that water will come out and the milk which I dissolve, that milk will stay back. So in the cloth also you can see that there are no particles which are stuck. But if we come to the case of your suspension, so what I do, again I place this piece of cloth here and I pour this suspension. So in case of suspension, you find that the liquid part has come out, and in the cloth, if you see properly, if it is clearly visible to you, not sure because it is too white. So there are actually pink suspended particles which have stuck to the piece of cloth. That means in case of suspension, the particles were quite big to be separated by the process of filtration, ordinary filtration. So these are the 5 comparative properties we can say in case of your solution, colloids and suspension. So these are the 3 types of mixture and their comparative properties that we discussed. First property, let me do a quick recap of the properties. First property was whether homogeneous or heterogeneous. Solution is homogeneous. Colloids appears to be homogeneous but is heterogeneous. Suspension is heterogeneous. Second property was visibility of particles. Particles are not visible to naked eye. Here also particles are not visible to naked eye. Here particles are visible to the naked eye. Third is scattering of light. Solutions do not cause scattering of light. Colloids and suspension cause scattering of light. Third, stability. Solution is a stable mixture. Colloids are also stable mixture, but suspension are unstable mixture. And separation. The particles of solution cannot be separated by simple filtration. In case of colloids also, particles cannot be separated by simple filtration. And in case of mixture, in case of your suspension, the particles can be separated by ordinary filtration. So these are the basic differences between your solutions, colloids and suspensions. Thank you.